It's 1 p.m. already. Maybe Pak Rustam could start.
Okay, we have to start.
Okay, I will. Yeah, I will share screen first.
Okay.
Okay.
Assalamualaikum warahmatullahi wabarakatuh. Dear participants.
Waalaikumsalam warahmatullahi wabarakatuh.
Dear students, dear colleagues, dear ladies and gentlemen, Assalamualaikum, good afternoon. Welcome to the webinar. Thank you for being here this afternoon. My name is Rustam Asnawi, the head of Electrical Engineering Study Program, Yogyakarta State University. It's my pleasure, it's my honor that I can have an opportunity to manage this webinar. As you know, this webinar was held in collaboration between IEEE Indonesian section and Electrical Engineering Study Program, Yogyakarta State University. Today, we are pleased to welcome Associate Professor Dr. Supavadee Aramvith, special and distinguished guest from Department of Electrical Engineering, Chulalongkorn University, Thailand. Dr. Supavadee is the candidate of IEEE 2021-2022 Region 10 Director Election. Her specialization is in video technology. Today, she will be sharing with as her proposed framework, her proposed framework on video anomaly detection based on deep spatio-temporal translation network, or DSTN. But ladies and gentlemen, before beginning our webinar, we are pleased to welcome Dr. Prima Dewi Purnamasari to deliver the opening speech for this webinar. Dr. Purnamasari is a lecturer in Electrical Engineering Department, Indonesia University, and currently she is the Vice Treasurer of IEEE Indonesia Section Chair. Directly, Dr. Prima, the time is yours, please.
Thank you, Pak Rustam Asnawi, Associate Professor Dr. Supavadee Aramvith, Dr. Rusnam Asnawi, Dr. Mufizar Rahmah, doctors, lecturers of Faculty of Engineering at Yogyakarta State University, distinguished guests, colleagues, students, ladies and gentlemen, Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
A prosperous, warm and spirited greeting. I am delighted to be here today on behalf of IEEE Indonesia section to give an opening remarks to the webinar Video Anomaly Detection for Intelligent Surveillance System. This webinar is a program of IEEE Indonesia section educational activities in collaboration with Yogyakarta State University. First of all, let me thank to Associate Professor Dr. Supavadee Aramvith, the candidate of 2021-2022 Director-elect from University, Thailand, for her knowledge of intelligence surveillance system. Also, thank you to Dr. Rusnam Asnawi as the head of the Electrical Engineering Study Program of the Yogyakarta National University to host this educational webinar. And also thank you to Dr. Mufizar Rahmah, the IEEE Indonesia Section Educational Activities Coordinator, to arrange this webinar. The IEEE is a non-profit organization which proposes to engage exclusively in scientific activities directed toward the advancement of the theory and practice of electrical, electronics, communications, and computer engineering, as well as computer science, the allied branches of engineering, and the related arts and sciences, which benefit the engineering profession and the public. We are grateful to all parties who work together to help arranging this very interesting webinar program, and we hope that this kind of educational webinar program will be regularly held in Yogyakarta State University in collaboration with IEEE educational activities. All in all, we hope you will enjoy your time to learn from Associate Professor Dr. Supavadee Aramvith and make this webinar a memorable event. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Dr. Prima, as the Vice Treasurer of IEEE Indonesian section. And again, on behalf of Electrical Engineering Study Program, we are thank you very much for IEEE Indonesian section upon your fully support for this amazing webinar. Okay, before we starting our webinar, allow me to introduce Associate Professor Dr. Supavadee. Dr. Supavadee Aramvith received the bachelor degree in computer science from Mahidol University in 1993. She received the master and PhD degrees in electrical engineering from University of Washington, USA, Seattle, USA, in 1996 and 2001, respectively. She joined at Chulalongkorn University in June 2001, and currently she is an associate professor at Department of Electrical Engineering with specialization video technology. Many papers about video technology already written and published in reputable publishers such as Scopus. Okay, before we starting, maybe we have some information about this session. For ladies and gentlemen and participants, if you have any question, please use the chat room, yeah, and in the chat column on Zoom by mentioning your name, organization, and then question. Next, moderator will curate and deliver the questions to speakers during the Q&A session. And then at the end of this session, webinar team will give a link to evaluate survey in the chat box for all participants to complete. Please complete the survey to have your data recorded in the attendance list. And then link to download e-certificate and the speaker's materials will be given 1 week after you submit your feedback, the survey. Therefore, please complete the survey. Okay, ladies and gentlemen, I think we are pleased to welcome our special guest, Dr. Supavadee, to start deliver your presentation. Dr. Supavadee, the time is yours. Okay, please, thank you.
Thank you very much, Dr. Prima, Mr. Rastam, for the kind introduction, and also for Murphysa for help coordinate this talk. So I have to share the screen. Maybe you need to give the authorization to me.
Okay.
Wait.
Just stop sharing first. Okay.
Please. YouTube in the host now.
Okay. Please.
Yeah, I think they should be fine. Yeah. So again, thank you for your kind introduction, and and as I was mentioned as the Region 10 candidate, the candidate for Region 10 Director-elect. So I have to introduce that there are 3 more candidates: Professor Lance Fung from Murdoch University, Australia, Professor Norisa Moore from University of Technology, Malaysia, and Professor Celia Shahnaz from Bangladesh University of Engineering and Technology. So there are totally 4 candidates for IEEE Region 10 Director-elect election. And I believe that maybe Indonesia section already cast their vote. The end of the vote is this coming Thursday, October 1st. I believe in Bangkok and Indonesia time is the same, is a 1 at 11 p.m. at night time. Yeah.
Yes.
So I do hope that Indonesia section cast their vote. Yeah. Yeah, so the topic today is one of my emerging research and that has been given a lot of attention, because one thing is about the difficulty of the work and also the practicality and the usefulness of the application as well, because that if we have CCTV camera, we do like to know what is wrong in the scene. Right? And then it's not that easy, because the scene can have a variety of the action and a lot of people, object, and so on, right? So today we just give you an idea of our work, and maybe you can find some scenario that also you could work on. Yeah. So I'm from Chulalongkorn University, and I'm currently also just recently I'm the head of the multimedia analytic and processing research unit. We just established this at our university this last month in August. Yeah. So Chulalongkorn University is the first established university in Thailand, and we are public and autonomous research university situated in the center of Bangkok. So of course, I do have many of the alumni from Indonesia, and of course, Murphisa Ovi is, I'm proudly to have her as one of our master graduate from my group. Yeah. We are the first ranked university, and you can see we are the comprehensive university. So it consists of all the field, and you can see this how many disciplines, how many college, how many programs that we have. Also the current student, and also in terms of the faculty staff. Yeah, and also we are proudly to be included at the rank 96 of the world top 100 university for academic reputation for QS World 2021. And as I was introduced before, I got my PhD, almost 20 years ago from University of Washington. So in Seattle, as you know, is or the headquarters of the Microsoft, of the Amazon, and then like now the Google also going up there, yeah, and have Boeing. So it's a center of like the high tech, the Silicon Valley. Of course, it is much different where it is from 20 years ago. So today Seattle is like more crowded and more expensive city. Yeah. So yeah, I have been working in Chulalongkorn for a long time, and of course I love studying, I love teaching, and I love doing research, and I love also to advise a student. So this is like the number of the student that have graduate on the group. So we have a very active we call video technology research group. And currently, okay, I also advise 2 postdoc and 6 PhD, 3 master, and 5 bachelor degree students. I think it's a good number, and we try to produce the quality publication, as possible. Other than that, we also I also work internationally. I'm the also associate head of internationalization. I'm just back to do administrative job after I was off for 4 years. Yeah. There are many things that I do internationally. Like I'm also involved in the ITU, which is the International Telecommunication Union. They're expert on ICT for Sustainable Development Goals. So I also have give a recent talk and involved in the BUSIS event of ITU. That was just weeks ago. I'm also help with the government, like a Ministry of Digital Economy and Society, and also the National Broadcasting and Telecommunication Commission as their technical advisor and some project consultation. And of course, I'm very active in IEEE and IEEE of Japan and Asia Pacific Signal Processing and Information Association. Yeah, other than that, I'm work collaboratively with Japan. As you can see, I'm visiting professor to Hokkaido University and Osaka University, KDDI Research Lab. Okay, I'm back also 1 month to my universities in Seattle 3 years ago. Yeah. So just briefly about IEEE, I'm a member already 25 years since my graduate student at University of Washington, and also I half of that time, which is like maybe 13 years, I work in the volunteer. So I have several of the volunteer position. Of course, I'm start with the Thailand section as a Thailand section secretary. And then I was later, 4 years later, I'm appointed in the region 10. I'm handling educational activities and women in engineering. And currently I'm handle the section and chapter committee, in which like I was delegated by regional director to approve the new section, the new subsection, or the new technical chapter. And I of course, I approved several of the joint chapter that were formed by Indonesia section, I mean earlier. Yeah, but other than that, IEEE is a very big organization, right? So it has several of the board. In region, we are under the MGA, Member and Geographic Activity, but there are also other board like a technical activity where there are many of the technical society that you can be a member. Okay, so I'm the board of governor of consumer electronics. And I'm so like the long-time member of signal processing, circuit and system, which is more of my main society. Okay, I'm a new member of the engineering, medical and biology society as well. And other than that, my contribution on educational activity has been long. So I'm in the educational activity board for 4 years. Okay, and I believe that I used to organize like a teacher in service program training, and I think OV who handling the educational activity in the section also has like done several activity on this as well, which is very good. We're gonna have the incoming the STEM volunteer portal, in which I hope that we could have volunteer from Indonesia section who join. Other than that, I'm the communication chair of Humanitarian Activity Committee. So, I mean, this committee, in New Initiative Committee and Engineering Project in Community Service, right? IEEE Foundation is the body that in IEEE that give a grant. So Humanitarian Activity, of course, cover in Indonesia. I believe there is an active upside group that, I mean, now they have the project for fighting the COVID. Right. So I mean, many things that, I mean, if you have several activity, right, you can, I mean, you can ask me, like there are many opportunities for you to get a grant and get activity ongoing. Yeah. So that's like a brief introduction about me and, I mean, the IEEE. So now, so to begin of the research, right, I would like to tell you first, what is the research that I'm interested in and I'm doing. So there are two main areas. The first one is the area that I do since like I study PhD is my main topic on the video compression and video coding. And then I am interested, of course, in the wireless video coding. And as you can see, all the application today, right, we have to compress the video because everything is in the digital domain, right? Like you can see my video now, video is compressed. And like on the 4G, 5G network, like, and when you do FaceTime, when you do like all the video call, or the streaming that you watch the movie, or the digital television and so on, it's like the video has to be compressed. And over time, the problem is still challenging because one thing that now we have a much higher resolution of the video. I mean, if we compare to 20, 30 years ago, right, it's a video now is a lot resolution, and then like television, you have the big wide screen, right? So video compressed, higher resolution, it needs the new standard over time. Every 5 years, we need to have a new standard, and the new standard is more complex compared to a previous standard. So there's a problem also of the optimization of the coding, so that when you do the compression, it's take like a shorter time. And then also in terms of like when you send over wireless, which is like a time varying nature, you can get a lot of error, like how to fix that. How the main thing is that we would like to get the compressed video quality at the best. Okay, I mean at the receiver. So that is like the work that we have been, I mean, continuing and doing. Yeah, and other work is the work that we will talk today. Okay, so it's a video analytic for surveillance application. Like, so we have so many CCTV camera. So somehow, how we could analyze, how we could extract some useful information, right? So not only that we have the camera act like an eye, right? And then how can we build an intelligent brain to the camera, so that we could somehow think or use experience like human to judge or to do the reasoning, like, oh, this is like a suspicious event, how can we know? Okay, so I mean, this area has been increasingly, I mean, the people work on it a lot. And of course, the number of publication is getting more difficult each day. And especially like today we have all the AI or the machine learning, deep learning coming in, right? So it's not too difficult for you to start research in this area because you don't start from zero. You just go to GitHub and you get some of the model and you're building on top of that. But of course, if you can do that, other people can do that as well. So it's mean in terms of the, like you think of the new thing and publish, right? You have to be very fast. So that would be a thing that like more competitive in terms of the research, but it's good to see that this area has deserved, I mean, a lot of attention, okay, this day. And other than that, of course, I work on several projects with Japan, and I'm also interested in the accessibility application or like a telehealth or the sign language, okay, for the deaf people. And some social media analysis, some of the like data mining, like this also very interesting, like for the vehicle tracking system, how can we do the risk map analysis and like give a warning to the driver if they're now driving in specific environment and go into the area that prone to get an accident, how can we warn them in advance. So this is, I also work with the Thailand company who manage a truck fleet, okay. So what we talk about today is a result of the research, right? So when we do the research, whether we are the academic professor or like we are the industry, like a researcher. So mainly, of course, research start with idea. We can get the idea from like reading the paper. We can get the idea from like talking, and then like or somehow we can have the technical background in that area that we think we could do something more useful. But anyway, idea is very important. It start off, I mean, everything. When you do thesis, okay, you need to get idea of how to solve a certain problem, right? But the end point is the realization, right? So realization would be the output, would be the outcome. But it depends on like if you are the PhD, you are the master student, then your outcome would be like a journal publication, right? Or I mean, if you want to work something, it can be a commercialized product. It can be a patent, right? So I mean, it can be many things in terms of realization. And of course, the distance, if you start doing it, it may be long, right? In a PhD, when you start your PhD, it's gonna be like a long road until you get the realization, right? But mainly the experience would I mean, forming you up to train you that this distance gonna be shorter. So this is like the quote that I mean, I love to give when I start the talk, right? And mainly, as I already mentioned, okay, why we need video analytics of so many CCTV camera each day. Of course, when we have many camera in the city, we would like to increase the public safety, right? So that is the main reason. But now, of course, by installing camera, you can also get other benefit, like the department store, they can count number of the people, so that or they can analyze, like if people stop in front of this merchandise for so long, so that can indicate the interest, mainly like from the facial expression. So that can be used on like a strategic planning in terms of the marketing thing, or in terms of a customer service as well, right? So I mean, it has so many advantages. And now also the camera, like we if we can analyze the face very well, we can also do something related to health as well, in which I'm also interested in that area. In if we can analyze face, right? So somehow it can indicate some health condition of a person. Okay, so that's the thing about the camera and how we can do things. I think it gives the extended, I mean, range of the application, and then I mean the usefulness, right? So I started doing the research in video analytics 15 years ago when I got the first grant from the Thailand government. That time is different from this time, because at that time we do not have AI, we don't have deep learning or CNN. So everything would based on like the pixel based processing, right? And then, I mean, of course, it gives some limitation, like if you want to detect something, then it need to be hard code. So I mean, if you want to cover all scenario, it's gonna be more difficult than you can do today if you can train CNN with a lot of data set, right? But anyway, at that time we start doing, so we know like what is the difference between before and today, right? So we do person detection and tracking, and then like super resolution, which is like today I'm still working on it because like with the deep learning, it give more it's not easier, but it give more opportunity for us to that we could expand. I mean, the reconstruct the high resolution of the images. Okay, but of course the talk today is not about super resolution. Maybe I give some more detail. So super resolution is mainly like when we have a camera, and then usually when we want to see a person or something, it may not be that clear because the person is quite far from the camera, or the environment, the light is quite dim, right? So there are many factors that when you just crop a face of the person, it's blur, right? And then if you want to find like a suspect in the scene, so it's not possible to do so. Even the face cannot be recognized, right? So we need the algorithm such that we could expand, I mean, the image, like upsample 2 times, 4 times, 8 times, so that we could reconstruct something that we could use it. So this is very important application, and it is still very difficult in terms of research, because now, of course, now like we can do 4 times well, but 8 times is still quite difficult. Okay. The next work is the human feature extraction. Okay. In which for this now you can find many library. If you want to find detect a color of the church or the clothing, or if wearing a hood, wear sunglasses or something, right? So somehow on this, I mean, now you can get the library. It's quite easy to do. Face cataloging is like a real-time face recognition. We're still doing this in terms of the hardware also. And monitoring and warning is something like relate to what I will give a talk today. Okay, so we can have some basic thing on the this suspicious alarm, like a zone alarm or cross-line alarm, where people want allowed to be in a certain area or walk in a certain direction. But if in terms of the level of suspicious, it is more difficult, because if for the old time that we cannot use the deep learning, so it's mean like we have to write a rule to handle certain scenario, like hand over the object, or people walk around too fast, something like that. Okay, but of course today is give more flexibility. And another work is a person tracking to multiple cooperative camera. This is also interesting work as well, but this work is something like people in computer vision would know. This still very difficult, even before and now, because like you're talking about when you want to analyze the image from the camera that installed in the different places, even in the same building but different floor. Yeah, I mean, it can have different environment. The light may not be the same, how the camera was mounted, right? So if we put the problem like when the person enter the first camera, and then the camera can recognize the person, and we can have an idea because all the camera would connect via the IP network, right? So it could send along information from the first to the second, third, and fourth camera, and so on, right? But if the idea is that if that person enter the third camera, so will information from the first camera can be used as a prior information, and then somehow could recognize the third person right away, right? So I mean, if it like that, it is very useful, because you don't need to perform all of the like detection, recognition, everything all over again, right? So you can have prior information. But one thing is that the image that come from the third camera may not be the same. Even somehow like the person face may get dark, and you cannot confirm that it is the same person or not. Okay, so that is the thing that is a difficult, I mean, in this task. Okay, so the research in surveillance video analytics today, I mean, this is what our group have been work on, right? And then mainly today about this anomaly detection, right? So one thing I would like to mention is that now the AI machine learning and deep learning has been used as a main tool for this kind of the research. Okay, and we all know that artificial intelligence mainly is about like how we could make the computer to mimic the human intelligence. So if we can remember things, if we can recognize a person, or we can know something is wrong, right? Because I mean, our brain have a capability to do that, right? And then if we go down to the machine learning, which is a subset of the AI, so this also include like if we can use statistical techniques, okay, so that and then we could use that to do the training, okay, of the data if you have many of the data set, right? So it's been when you can remember thing or the algorithm can remember some object and so on, it could be easier because if you get a lot of training over time, you tend to do something better. Okay, and then we go down to the deep learning, which also the smallest subset. Okay, so in deep learning, right, we try to build the brain. The brain is mean like we have all the neuron, billion of the neuron that connect in our human brain. So if we think that we could build something like that, like the convolutional neural network, right, that consists of a lot of the layer, and each layer is go through like some kind of the extract the useful information one after another, right? So it would be, I mean, very useful that we could use that capability, okay, to do the recognition, I mean, at the higher accuracy, right? So I mean, today this is the technique that, I mean, we use. And then I just want to give briefly information about the machine learning model, okay? Because what we do is also the same. Okay, so I just want to give the problem definition that we would, if we want to classify like a cat from dogs or the dog from each other. Okay, so how would you do that? Of course, you will need a lot of data set. If you have as many data set to train, it is very useful because, I mean, when we do the training, we try to extract information. It's like we remember, right, what is the key feature of that specific cat, or make it different from dog, right? So in the training, so machine learning model consists of training and then testing or prediction phase. And in training, right, mainly, of course, you're gonna label this is the cat, and then you extract that feature, okay, so that, I mean, you could I mean, accumulate that feature, so such that we know that it can identify cats, right? And then in terms of, and so this you're gonna do a lot of training with a lot of data set, okay? And then in the training, they also have what we call validation phase. Validation is mean like how can you know that when you do the extraction and something that you can do it like with the greater accuracy, so that when it go to the classifier, it can classify correctly, like. So we have to do some like some small testing in the training we call validation, right? So validation could tell you that how much accuracy you can get, and then allow you to adjust some parameter, like in the CNN, in the training and so on, so you can get a greater accuracy. So training gonna consist of the training phase and validation phase. And typically you're gonna use different data set on that. And then for the testing and then the prediction, right? So this is the one that you're gonna use that trend classifier. Okay, so that, I mean, now you could do actual classified tasks. Right. So you're gonna use different data set as well. Okay, so mainly these are the machine learning consists of mainly three: training, validation, and then the testing or prediction. Okay. So now we start talking about the anomaly detection for surveillance video. So this is a recent work of my PhD student that we get published on the IEEE Access on this March, the past March. Okay, and the work is also collaborate with Professor Nikusebe from University of Trento in Italy. Okay, so when we talk about anomaly is something that we call like it's deviate from what is standard, what is normal, or what is expected. Okay, so the very simple example in this talk, now I'm the only one who speak, right? So given the fact that I'm do something deviate from others attendees, right? So it's mean now I am the anomaly, okay, in this situation. So anomaly is mean like you can it's the event specific, right? So it's mean in different scene you can have different anomaly, right? But one thing is like how we could of course, first we have to identify anomaly, and next we have to identify from the scene that this scene has anomaly. Okay, so this is like the concept. And if you see the video, you could see that people are walking is like normal, right? Because that's the main pattern in the scene. And if the truck come in and then people ride the bicycle in, it could now consider as an anomaly. Right? So in the framework of the anomaly detection, okay, how could we accomplish the task? Of course, it consists of, you have a raw input, you're gonna extract the feature, and then you detect anomaly. And as you can see, it's like, oh, toolbox is that easy, right? But it's not that easy, because feature extraction, like what kind of a feature you could extract? It can be spatial feature or something within one image, right? So it can be the traditional handcraft feature, like a histogram of Gaussian, or the scale invariant, I mean, the shift algorithm, or it can be also a convolutional neural network, okay? And the temporal feature is like applied to the video, right? So you could do the optical flow trajectory so that you could detect some movement that happened in the scene, okay? So that's the feature extraction. Then for the anomaly detector, right? So it's when you need to have like the approach of the classifier. It can be the normal classifier such as Naive, Bay, or KNN, or the SVM. Okay, or it can be the neural network, in which like the approach that commonly used now, like a CNN autoencoder or generative adversarial network. So after the anomaly detector, you're gonna get like something out like what is a normal or what is the anomalous. Okay. And then if we go into the anomaly detector, we do have the approach that, do we like to classify the normal event, or do we want to classify the anomaly event? It can go two ways. So if for the normal event characterization, it can be structured, it can be unstructured, right? So it means if you have object in the scene, will you label every object, right? Or you not label any object? Or if you focus on like you want to identify the anomaly event, it can be supervised, semi-supervised, or unsupervised, right? It means that, again, if supervised, then you're gonna label all the anomaly sample that available, right? Or semi is some part of it. Or unsupervised, you do not label anything. You just let the algorithm learn from the scene. Of course, in our work, it is unsupervised. We do not label anything, okay? So when we choose the unsupervised learning, then we have to choose like what would be the state of the art of the feature extractor that we're gonna use. And again, as I mentioned, there are so many research in this area. You don't need to build your own feature extractor, right? You can, but mainly you have to do the extensive review of what are the state of the art algorithm out there for the I mean spatial feature, and then also the temporal feature. Okay, so you have to review, okay, and which one you're gonna choose, okay, and also classification as well. There are many of the method, right? So we have to see, I mean, what we will use. Okay. So I mean, the motivation and problem statement of the research, of course, is that in our case, we would like to detect like the crowded scene. So it's been the scene with a lot of people in it. Okay, and then but one challenge is that, of course, when we do the research, we have to have a data set that we could do all the training and so on. But somehow the data set in this area, in this anomaly research, is quite small. It's not that many, right? Not that many. But if you want to publish, you still have to work on this kind of the data set. So that limit also the scenario that we could work on. Okay, so that is one of the challenges. But of course, if we do research in this area, we could also produce our own data set and share with other, I mean, as well. And also some kind of how we can locate the object accurately in the scene. Okay, that also another problem. Okay, and then also like how we can use the spatial feature and temporal feature at like at this maximum potential to help identify something in the scene. So our approach, we also based on the GAN, okay, or the generative adversarial network. I'm not sure that you have, heard about GAN, okay, but GAN has been also used like in the super resolution problem, and it has a capability that it can reproduce the image that more beautiful than our normal image. Okay, that was GAN is so powerful. So GAN or generative adversarial network, it is an outstanding approach to overcome data generation and then the classification problem in the complex tasks. And then it's also good at the data augmentation on the same small data set, okay, and then implicit the data management, okay, as the challenges that between two network, okay, it has the two network as you can see here. So GAN, it will have one that called generator and other one that is called the discriminator, okay. So in general, okay, the generator would produce the synthetic image or the fake image from the input random noise C, while the discriminator would try to attempt to differentiate between fake and then the real image, right? So mainly the goal of the generator are to generate synthesized sample of the object, okay, that look like the real one, and then attempt to fool the discriminator to make a wrong decision that the synthetic data generated by the generator are real, okay. So it means on the other hand, if we look at the discriminator, right, it's also has been learned on the data set, the label of the image, okay. So discriminator will also try its best to discriminate whether the input data are fake or real by comparing them with the real training data, okay. So it can be assumed if like giving an example, like a generator is like a counterfeit producing the fake check, while discriminator is the officer trying to catch the generator, okay. So since the anomaly detection, right, is a complex task, and then with the small data set, that's make the generator adversarial network GAN is suitable for anomaly detection tasks, okay, especially in the manner of the unsupervised learning, okay. So what are our methodology? Okay, so mainly our method, we consist of the we use the DSTN. DSTN is called the Deep Spatial Temporal Network. Okay, so in our proposed DSTN, okay, we based on the generative adversarial network or GAN, and we additionally plug in with some pre-processing and post-processing procedure, okay, to improve the performance in the learning normality and localizing normality, okay. We also aim to get the information from both appearance and motion representation, okay. So overall, you can see that our main component is consists of like the feature collection, the spatial temporal translation, differentiation, and then the edge wrapping, okay. So in the feature collection is the key initial process for extracting the appearance of the object. Okay, so the features are fed into the model to learn the normal patterns. In our case, like the generator G here, okay, it's used for both training and testing time, and discriminator D, it used only at the training time. Okay, so during the training, okay, G generator will learn the normal pattern from the training video. Okay, so it can understand and has only the knowledge of what normal pattern look like. The reason that why we fed only the frame of the normal pattern is that we need the model to be flexible and able to handle all of the possible anomalous event in the real world environment without a label of the anomaly. Okay. So specifically, we input the normal event. My picture is gone. We input the normal event of the original frame F, okay, with the background removal frame FBR, into the generator, which contain the encoder and then the decoder, okay, to generate dense optical flow of the frame. This is an OF gen here, and it represents the motion of the normal object, okay. And then also to get the good optical flow, we need to fuse the real this optical flow frame, okay, and then the background subtraction frame to eliminate the noise that frequently occur, okay, so that this fuse dense optical flow frame, I mean, could be more accurate, okay. And after that, the patch, okay, we have the several patch here, here, and here. We'll concatenate, and I mean, first these two will fed into the generator to produce the patch of the this OF gen, and then while the discriminator, okay, will have the two alternate input, okay, the patch of the real optical flow image and the patch from the synthetic optical flow image, okay. And then they try to discriminate whether, okay, the output from here is the fake or real, okay. So that is like the main idea of our DSTN, and then also for the training, okay. But of course, I mean, if you do not have a background on this, you can ask me later on, or you could study more on our paper if give more detail, okay. And then now we come to the testing. And then you can see like the testing is very similar to the training, okay, except that now we do not have the discriminator, okay. So after we do the training, right, the STN model now understand the mapping of the appearance representation of the normal event to its corresponding dense optical flow, which is a motion representation. So all parameters that are used in the training will also use in the testing, okay. So in testing, all the frame of the normal and abnormal event are input into the model, where the generator will try to reconstruct the appearance and the motion representation from the learned normal events, okay. But however, okay, the generator has not learned the abnormal sample. Please remember that in the training, the generator learned what is normal, but not the abnormal one, okay. So of course, the generator would be, I mean, it's not able to reconstruct, okay, the abnormal area properly, okay. So it would give the reconstruction result as the unstructured blob, okay. And then we use this inability, okay, to correctly reconstruct anomalous event in order to detect the abnormality, okay. So we can find the differentiation by subtracting the pixel in the local area between the synthesized image, okay, I mean that this the patch of this one with the real image, okay. And then in addition, not only the anomaly detection is important on the real world use, but also in terms of the, I mean, anomaly localization. So I mean, this is shown like how we could do in the testing, okay. And then after that, after this differentiation, we do the edge wrapping, okay, so that, I mean, we could get the precise area of the abnormal object, okay. So and then that we get the result of the output, okay. So mainly these are the idea, like how we compose the model, and then we do the training and then the testing based on like the generative adversarial network and all the feature collection. So all the experimental result, we use the UCSD dataset, okay, which is like a people walking in the scene, and mainly two evaluation criteria that we do is at the frame level and also at the pixel level. And then this is like the example of the dataset. It's the pedestrian dataset. It like a PET1 consists of the 34 training and 16 testing image sequences. So you can see like the resolution and how many of the like the 3,400 anomalous frame and 5,000 normal frame. And the PET2, okay, PET2 is something like has more anomalous than the normal events. Okay. And there also the another like a UMI dataset that has 11 video on the different indoor and outdoor scene. This has like 7,700 frame. And Avenue dataset is consists of the frame 30,000 over frame, and then it has a 15 frame from the 16 training video, okay, and 15,000 frame for the 21 test video, okay. So these are the data set that, I mean, we use, okay, for the for the training and then the testing. And then also these are some of the, like we have to use, of course, the GPU to train, and then it's quite extensive time to train, even if the best GPU that have. Okay, so here we could see like for our testing, we can see that we got the time complexity is around 3 frames per second. And because we use the unsupervised learning, it can detect, so many of the scenario that differentiate from the walking. Okay, and then here we could see like the highlight is the one that we detect that it is an anomaly in the scene. So here like we learn like if people walking even not in the straight direction, like and then after that, if the people run out of the scene, this can signify, the abnormal crowd scene, right? If the people run out. And I believe this, you could see like a very easily that if something gets wrong in the scene and people would run out, right? So if in this case, if we like wait for someone to run out and catch the police or some guard to be here, it may not be on time. It's good if we have the system to be able to give a warning first, right? And in this as well, like if the child jumping or the people throwing the paper, you can also know that it is abnormal in the scene, right? So this is like the example that what we do, okay? But of course, now what we do here, because we have to publish, so we have to use this data set. But it is very useful that we need to also to learn from the real scene. So other work now that we're doing is that we try to learn from the everyday, because we have CCTV camera in the building. So we try to learn the scene every day, and then later on we will try to identify what are the abnormal events, from that scene. That is like the ongoing work. So other than like the video result, right? We also show the plot in the ROC, okay, or the receiver operating characteristic, which is like if you are published something, you need to plot this curve against other work in this area. And of course, in this curve, we plot it for the different of the data set, like a PET1, PET2, and we do it also at the frame level and then the pixel level. And this you could show, you could see that our algorithm is the one in the circle and blue that locate toward the top left. Okay, top left. So it's mean if ROC characteristic, the more preferable is the one that go toward the top left area, determine that, you do better than, other method. Okay. So, to produce this ROC curve, we have a threshold parameter that we have to vary from 0 to 1 to indicate, okay, mainly to indicate the true positive rate and then the false positive rate. Okay, and then we compare performance with the state-of-the-art algorithm. Okay, and then we can see that our curve has the strongest growth on the true positive rate. It means like the abnormal event in our proposed method are accurately detected and localized in both frame level and then the pixel level evaluation. Okay, so this is like is this enough to validate, okay, the result of the algorithm, that our algorithm are robust and also quite effective. Okay, and these are also some other of the result, because when we do, we also we also do not only confirm on the final outcome, which is good, right? But along the way, we have to testing like the other algorithm in between as well. Like for example, we use the background removal method, right? So we have to compare that which state-of-the-art algorithm that we choose is this good compared to other method. Like in this case, we compare with the Gaussian mixture model, okay, of the background subtraction and then our proposed background subtraction method. And then you could see that like here we are the method is better in terms of like the when it's can identify the segmented object. Okay, and then also in terms of the generator. Okay, so image generation. Okay, we also compare use with the autoencoder. Okay, and then also like the residual connection. Okay, and so on. But somehow we use the dense optical flow. Okay, so we can see like for the example, and this also in terms of discriminator. Okay, what would be the size of the patch GAN, right? So like what is a 64 times 64 pixel is, I mean, better than 32 times 32, something like that. Okay, and also we have this edge wrapping at the end so that we could localize the anomaly object better. Okay, and then we could see like with varying of the threshold, what is, I mean, the base that preserve the edge and other of the threshold value. And this is also like the STN with the edge wrapping. Okay. So we do have the CCTV surveillance camera testbed at the lab on the building 13 and 12 and 13 floor. So we have 40 indoor CCTV camera in which we receive for different of the project. Okay, and then that's how we could also doing the normal scene that we trying now. And then I also think that it's very important that we could implement the solution on the hardware. And I think that today we are like I mean, we are in the period that we have so many of the single board computer that like small and also capable. Like the one that also we use for our face recognition work is the NVIDIA Jetson. It contains the GPU in here. But of course, other type, if it's too small, it means that it cannot put the CNN in there, right? So you're gonna need something that is more capable, but of course the cost would be more expensive. We also work on the FPGA before, okay, like several of the project and also the system on chip. But of course today, like Intel and other company, they are come up with the FPGA board that lower price and then has a capability as well. I mean, to do all of the computer vision and AI tasks. Okay, so it will come out. It come out already, I believe. And then we have worked on some, and then it will be in competition with the GPU, because now if we want to do all the deep learning, we need the like all the big GPU server, and it's quite costly, right? And then if we want to implement the solution on the hardware and not the cloud, so it means you need other kind of solution, which is the FPGA board that come out. And then expected application would be like some of the IoT sensor that if we could detect, I mean, several something that anomalous in the classroom, in the hallway, like in the stairway, right? And then also in terms of the outdoor application, right? People with unusual behavior, okay, on something like monitoring the large area farm or the fire and so on, okay. So we can see many, I mean, useful application from the video analytics. And specifically today, we touch on the video anomaly detection. So you could see that the deep learning and CNN push the limit of the video analytics. And then also the pre-processing of the input image is extremely important. That's why I'm still spend my energy focus on the super resolution, because it could put at the pre-processing, and then it could improve the accuracy of the recognition or the classification system. Hardware solution is very important. So we have to see the choice of the hardware. We have to see how we can optimize the algorithm based on the specific resource that we have on that particular hardware. And I still believe that solution within a cloud is important, right? I mean, everything now today, we're gonna throw everything to the cloud, right? But I mean, we may need some scenario that we could live without the internet, and then some solution with a cloud is still like a prefer. Okay, and if for the last CCTV system, the efficient video research, video search is very important. Okay, and this just to show like a deep learning online courses, like for the student if you are interested. like the Professor Andrew from Stanford University has the popular his course on the course A. And if you want to learn, of course, Python is a common language for this kind of the application. So you could learn now from the internet. Okay, there are some computer vision and deep learning online learning. And the top, of course, programming language, typically we use Python, right? And some use C and C++. And also framework is something that very important. The top two framework that people use a lot is a TensorFlow by Google and PyTorch, or TensorFlow, and PyTorch, of course, for the Facebook. Okay, and then Keras also has been used, but Keras also now is in the TensorFlow. So in our group, of course, we have majority using TensorFlow, and still some students use PyTorch. Okay. So thank you very much for your attention for this talk, and then you can always connect to me via the email, my Facebook and page. Okay. So I hope today I give the information that's for the audience and then also the student in this area. Yeah, I welcome any question if you may have.
Okay, thank you, Dr. Supavadee. There are two questions. Okay, directly we move to Q&A question section. Yeah, Q&A section. There are two questions, Dr. Supavadee.
Mm-hmm.
For the first one, good afternoon, Professor. Let me introduce myself. I am Hilal Yahya, student from Yogyakarta State University, Electrical Engineering. As we know, using camera is only outputting two-dimensional information. In some case, it might be crucial to have depth information for anomaly detection.
Mm-hmm.
Using stereo camera might be the answer, but not best answer for cost optimal.
Yeah.
Is there any way using mainstream camera for getting depth information, and how accurate is it?
I see. Yeah, I agree that, I mean, in terms of of course, if can get more information, it would be quite useful, right? But because of the cost, the camera with the depth maybe make it not that cost effective to the system. But of course, there are certain algorithms that you can still use to, I mean, because mainly from the real scene to the regular camera, you have to map from 3-dimension to 2-dimension. I mean, anyway, right? So it's mean you have to choose the algorithm that do the effective mapping in such case, right? The camera model that suitable. And also in terms of like the motion model that we use could also give more accurate even you don't have the depth information. Like for example, we use the optical flow or something that it could give accurate motion estimation. I mean, in the scene. Yeah. So I believe that without using the depth information, is rely on like the specific model that we can use for the feature extraction, in which now there are many. Yeah, so like the optical flow is like a very good example. Yeah.
So it means that using a regular camera can, yeah? Using CCTV.
Yeah, can, but it's just like the mapping from 3D to 2D, what the model that you use, and then also in terms of like when you would like to extract information from the scene, because like of course there are more complex model that you could be able to like model the motion in the scene more accurately. Yeah, because like for example like something like this, we have to focus on like the feature extractor, because there are many state of the art, right? So we have to choose that in offset of like if we lack the depth information. Yeah,
because the main key is the algorithm itself.
Yeah.
How to.
Yeah, because of course we do not use depth information, I mean, in this case, because also the processing time and the cost of the camera is not practical.
Okay. Next question. It's come from Karunia Nurdava Ramadan, also from Electrical Engineering, Yogyakarta State University. We know that video anomaly detection detects the anomalies based on the frames that it collected in the dataset. After processing the frames and defining the normal situation, what if the system makes the wrong decision, like decided the abnormal event as the normal event? It means that we will get wrong result. How can it be solved, Prof? Thank you.
Yeah, of course, I believe that when we do the testing, yeah, that may be some of the result that get wrong. Yeah, because mainly like the false positive rate is I mean it's not zero. Okay, so that there still be some cases that I mean not correctly, but I believe that mainly because as I mentioned to you in the training, we're gonna have the validation phase. Right. So if when we do the training and then when we do the validation, okay, we can tell that how is the true positive rate or the false positive rate. So we have to adjust the parameter and train again. Yeah, and then of course if we have more variety of the data set, so it would be more useful. But also depend on the model as well, because sometimes you train too much, too many, okay, and then it's gonna result in the overfitting. But of course, it's not happen in this case because we have the small data set only. Yeah, so it's been it's gonna fix at the validation can help. You need validation training. I mean validation phase to help adjust the parameter of the training, so that it could reduce the false positive rate.
Okay, Dr. Supavadee, next questions come from Dr. Nurhening, it's my colleague. Could you please tell us more detail what pre-processing done to the image?
Pre-processing?
Pre-processing. What
Yeah,
pre-processing?
I mean, in general sense, pre-processing is something like, for example, you want to remove the noise, right?
Remove
Or
the background.
maybe you want image enhancement, right? Or that super resolution is called the pre-processing, because if you receive the image that is not clear from the camera, and we have to make it clearer before we put it into the CNN or some deep learning, right? So to do the feature extraction, because if we do not do pre-processing, it means you get some blur image into the feature extraction. It's going to result, so feature extraction cannot extract the feature correctly. And then after that, it will learn the wrong thing, right? Everything would be a failure. So mainly having pre-processing before you do the processing, you do all the feature extraction, and then the deep learning model is very important.
Okay, I think it's clear. Dr. Nurhening, yeah, you can give a feedback again, maybe.
Okay, thank you so much.
Okay, thank you. Next question comes from Iqbal Amza. He is from Mechatronic Department. My question, are the smallest image resolution so that the anomalies can be detected, and how efficient the detection system in dark situation or in the low light?
You mean low light, and then what other kind of situation that was mentioned?
Dark situation, low light, there is no any.
Dark situation.
Or dark, which is low light, right? Dark.
Dark, yeah.
Right.
I mean, of course, I mean, in that case, it is more useful to, but I'm not sure what is, if of course, if it's too dark that you cannot extract the object, of course, you have to do pre-processing first. Your algorithm have to handle that first before you do the feature extraction.
Yeah, I think it's difficult.
But I think I mean, just in this data set, I believe that yeah, it is not have that lighting problem or something. Yeah. But of course, if it is the case, then we need to enhance the light first before we put it in. Yeah, we need some algorithm before that.
Okay, I
Is
think.
it real time, Achan?
Yeah, it's real time.
Can I ask, because it's real time, but
It's real time, but not
the analysis.
because like it has to.
Sorry.
Yeah, it's real time.
Real time. I think real time, right?
Yeah, real time. Like when we the
I
capturing
see.
this real time when we do the demo. Yeah.
Dr. Supavadee.
Because of course
So the feed.
the training and testing is the training is take time, like a train like a month or something. But when we do the actual classification, is on the testing, right? So mainly on the testing is real time. Yeah.
Maybe do you create a library for Python or for C++? Visual C#, a
One
library?
is on Python. Yes, on Python.
Python.
I think Python and TensorFlow. This one. Yeah.
No, maybe you can create a library, a particular library for your proposed framework, so anyone can use the library. So anyone.
You mean if we can share like
Yes.
the work, right?
Yes.
Yeah, I think my student she will do it. I'm not sure that she already shared for her first paper, because now she's still submitting her second paper. So yeah, at a certain point she will have to share because we need someone to compare our algorithm to as well for the citation. So yeah, she's gonna do it. I believe, of course, within this year we're gonna have it on the GitHub. Yeah.
Okay, thank you very much for your very interesting presentation, Dr. Supavadee.
Pak Rustam,
Yes. Any information?
one question left.
Oh, yeah.
Yeah.
One question still.
Yeah.
Just coming.
Oh, sorry. Yeah.
New question.
Coming from Yusuf Praditya Rahman. Yeah. Okay. From Education of Electrical Engineering, Yogyakarta State University. My question is, can we use supervised learning in video anomaly detection instead of unsupervised learning? And what is the difference?
Yeah, actually supervised learning would be easier, right? Would be easier because you can label everything, so you can know in advance. Yeah, but of course, first you need data set that's pre-labeled, right? Which is not usually available. And if you want to label it yourself, it's time consuming. I mean, you have to label on every frame. This is a person, this person, one with something like that. Yeah. But of course, with the with the supervised is somehow easier for specific scenario. If you know exactly what's gonna happen, and like if for example like scenario people fall down, like if people fall down and you in that scene you want to detect the people fall down only, so you can like building a training data set that you make it happen, like people fall down, you just label it something like that. Yeah. So I believe supervised is more useful for specific event, make the task easier. Yeah, and maybe you don't need to do a lot of learning data, training a lot of data set. Yeah, but unsupervised is more flexible. With one algorithm, we can work with this 4-5 data set. Yeah, because if we have to label, it's quite difficult. So it depends on the scenario. That if you want specific scenario, then you can do supervised learning. If you want to handle various kind of the anomaly event, it's better to do unsupervised.
Dr. Supavadee, in the programming level, what is the difference between supervised and unsupervised program? Maybe it's more consumer.
So mainly it's like it is more like also on the data set that you have to specify because you have to label, right? When you have to label, is when you have to label this person number 1, number 2, number 3, or somehow you have to also label this is abnormal. In the supervise, you're going to tell exactly that is the abnormal, like when the people jumping is abnormal, you have to label it. Yeah, you label it. I mean the training, and also do we have any example? Yeah, mainly you have to label it. Yeah. At the first, at the training, you have to label everything on every frame. Yeah. So to tell that this is abnormal.
Okay. Any question from participant?
I think I will have the work of the bachelor degree, like senior project student who will do anomaly detection, but because that scope is, because that is only bachelor degree level, so they're gonna do supervised case of the anomaly. Yeah. So in that case, of course, later if they have some improvement, then I can show you what is like about. But now we didn't do anything supervised, so I don't have any example to show. Yeah. Yeah, remember we have the camera in the hallway in the elevator. So they're gonna mainly
Yes.
we're gonna collect video that people come in and out of the elevator in that hallway. And like if people fall down or certain scenario, then we're gonna detect that it is abnormal. But for that is a specific, like they're gonna interested mainly just people fall down, something like that. Yeah. If people fall down to the floor. Yeah, yeah. So that would be supervised. Yeah. Mm-hmm.
Achan, I would like to ask, you said that the pre-processing use super resolution.
Mm-hmm.
Super resolution, you said.
Yeah, but
And
it's
before I know this, the super resolution makes the computation kind of somehow it's difficult to be real time. So what did you and your team do for that case?
I mean, of course now we can, because before if you just use the pixel based like interpolation for the super resolution, it take a lot of time. But now because we use the CNN, the deep learning. Yeah, so the deep learning is mean you spend more time on the training, right? But testing, it will be fast. Testing is fast, but of course we need to optimize the model, the CNN model. Yeah, so it means in terms of the super resolution now it is possible for real time because of the CNN. But we can spend time training for like a month also. Yeah, yeah. But and then you just get.
How
like,
long it takes to train?
It's depending. It's month. Some, I mean, depend on how many images. It can take several weeks and months. Yeah, but now we have 4 GPU and sometimes they use a Google Colab. Yeah, on the cloud, so they will manage. Yeah, but it takes time for training. And this one as well. This anomaly detection is take months to train. Yeah, and one thing about when you do deep learning, right? It is like you have to configure everything correctly because you're gonna let it train for months. And if something wrong and you discover that, oh, you set some wrong parameter or something, you have to redo it again. So yeah. But of course, not every task need deep learning, because deep learning you have to spend a lot of time training, right? If you know your scope of work, that you're gonna want to detect just deep. You don't need deep learning. Maybe they're just single case. You just do picture processing and something. Yeah. But if something like maybe it has to be scope, you want to classify many objects or something like that, then you need deep learning. Yeah. So you have to see the scope of the problem as well. But otherwise, it just wastes the resource to train for a month just to detect one thing, something like that. Yeah.
Okay.
But of course, students will think that,
Thank you, Achan.
I don't need to start from zero, because deep learning, you can just get the model from the internet, right? You can get the model. You can start with the model, but more importantly, you need to understand what's inside the model, which is not people understand. They just, oh, if they throw this in, they get this out, it looks good. Then just, but you need to modify the model, update that as well. Yeah.
Okay. Right. Thank you, Achan.
Okay.
Okay. Thanks, Ina. Any question? No? For participant, please fill in the survey form, evaluation form, sorry.
Good. It's quite a good attentive though, right?
Please turn on the cameras. Anak-anak tolong kameranya dinyalakan dulu, kita ambil foto.
Please switch on
Okay,
your camera.
Please turn on your cameras, guys. We would like to take pictures. Okay, group pictures virtually.
Okay. Ada yang belum? Please switch on your camera.
I cannot see you, Achan.
Huh? You cannot see me?
Okay, I cannot see you. It's black. Yes.
Huh? No, my camera is on. I still see myself. Can you see me?
Yes,
No?
I can see.
Oh, you can see. Okay, maybe my connection. Okay. If for those of you who have camera installed, it's okay. But for those of you who can turn on the camera, please.
Most of people, students can turn on the.
Yeah. Wow. Some of them can, but they are on another people here, so it's like the ones that turn on the camera is on another page. So it's okay.
No,
They are
I
here.
think you can set to show only the people who have the camera to show. Also, that also possible.
How to do? I've never done that. How to do that, Achan? Do you know?
Miss Sophie, there are 4 pages, so you have to screenshot 4 pages.
Yeah, you have to go to the next screen.
Wait.
Yeah, full screen. Yeah.
Prof, I send you pictures. Can you see? I send you pictures in WhatsApp if you want to see.
Okay, let me check.
There are 3 pages in my view.
Oh, it's really nice. Thank you, Dr. Prima. She took
Thank
the
you, Dr.
pictures.
Prima,
Very nice.
Yeah, okay.
I will share it later to you guys. Okay,
Yeah.
thank you so much, Bu Prima.
Yeah, welcome.
Okay.
Yeah, thank you very much for having me today. It has been enjoyable, and also the sharing and the question and answer. Yeah.
Thank you very much, Dr.
Okay, thank you very
Supavadee.
much, Dr. Supavadee.
Okay. Yeah.
Okay,
So please take care, everyone. Yeah, hope everything is getting better on the COVID, so we can live normal again. Yeah. Take care.
Is there any closing speech from Dr. Prima?
No, I don't have. Please, Pak.
Okay, dear participants, dear colleagues, and dear ladies and gentlemen, I think it's enough. And thank you very much for your joining in this webinar. Maybe we can see for the next webinar again, for the next amazing webinar. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you. Okay. Yeah, bye-bye.
Mohon maaf.
Yeah.
Waalaikumsalam.